Welcome back to the Impact Stage here at Techsylvania, and we have a very exciting new speaker. Rolf Jensen is the SVP of Engineering at Tradeshift, the business commerce company, where he runs engineering and platform operation efforts from the 200-odd engineers at Tradeshift. Rolf started when Tradeshift was still in a garage and with a title of Code Monkey, and has grown with the company, being part of the journey and inherent challenges: culture, organization, staffing, and of course, his specialty, technical. So please welcome Rolf Jensen to the Impact Stage for a talk on Tradeshift. We've processed $1 trillion. How? We're gonna find out. Rolf, welcome to the Impact Stage.
Thank you, Trevor. That was quite the introduction, and I'm sort of having this mental image of a large crowd going, woo, which is super exciting. So super happy to be here today, and very, very happy to have the opportunity to speak here and to, really just spend a little bit of time with you and thank you for your attention already now. And hang on, well, I just have to make grant a few access here. 2 seconds.
Oh no, what happened here? I think we accidentally lost Rolf here for a second.
Let's see. There we go.
Awesome. Hey, welcome back. Welcome back.
Welcome back. Somebody, I was in a call just last week, and somebody said, you know, Murphy's always riding backseat on any event. Murphy's Law applied also here. Let's see. Hopefully, you guys can see my screen now. Trevor, can you
all
confirm?
Good. Everything's all good. I'll leave you to it.
Awesome. Thank you very much. Appreciate it. Sorry, everybody. Hope you stay tuned. And thank you for the introduction, Trevor. And so moving straight into the content here, as Trevor said, my name is Rolf Njor Jensen. I'm originally from Denmark, live now in the Bay Area. I've been with Tradeshift since we started, and we were actually in a garage, from which I can tell you that starting a company in a garage sounds very Silicon Valley-ish, but it is also a bad idea in November in Denmark, because it'll be a lot colder. So with that, and my screen share died again. Let's see, what is this all about? There we go. All right. So moving into the meat of the presentation here, $1 trillion, how? And obviously, doing conference talks like this, you want to make sure you get a catchy title. And I thought this one was one that probably could raise a few eyebrows. 1 trillion is after all a big number, and few of us actually get to sort of mess around with something like $1 trillion. And it's a milestone that we recently passed in Tradeshift, where we actually saw that we had processed worth more than $1 trillion worth of transactions on the Tradeshift network since we started back around 10 years ago. And more notably, so we had doubled from 500 billion to about $1 trillion in less than 24 months. So also on a very steep growth trajectory. Now, what sort of putting a little bit more of an image to this and sort of giving you a little bit of an idea about what Tradeshift really is and means, this is from our internal data warehouse, where we look at aggregated sort of stats on the data that comes from processing all these transactions between companies everywhere in the globe. And when we say everywhere in the globe, we really mean that, right? So what you see here is, of course, a world map with transactions flying back and forth, and they're anonymized, so it's from the center of each country. And as you see, it really is traffic everywhere. And at some point, we had a live visualization of this going on, where you could actually see sort of value move across the globe, which was pretty exciting. And the other piece is a heat map, where you see sellers and buyers in different countries, and how how we actually have lots and lots of inter or intra-company, intra-country trade going on. What this allows us to do, and to sort of give you an idea about the scope of the data that we have, is that about a year ago, actually, as the whole world went into COVID lockdown across the world, we started to take a hard look at our data and pair it up with some super good analysts, and we're actually able to say something about the state of the global economy from what we have. And if you're interested in that kind of sort of knowledge and material, we publish this regularly either from our homepage or our Twitter account, Tradeshift, where we publish our quarterly insights into global trade report. And it does allow us to say something that actually has sort of novel information quality, right? And so all of this really is to give you some sense of what $1 trillion is. Moving $1 trillion, or having the insight into how $1 trillion move in the global economy, is enough to start saying something about how the global economy is developing. And why is that sort of important? It's important because what we are trying to do with Tradeshift is to connect every company in the world and create economic opportunity for all. And the reason I think it's important to just dwell on this a little bit is, and the reason that I've been keeping with Tradeshift for many years here, is that this is really exciting. This is really exciting to me, that by working for and with Tradeshift, we're building something, and we have an ambition to do something that leaves a footprint in the world. And hopefully also we can help, not just hopefully, but we're actively working to do so. We can change the world a little bit to the better and sort of do our part, right? So when we say creating economic opportunity for all, this is not just about taking the world's biggest companies and sort of bettering it for them, but it's taking every company in the world and creating an increased opportunity for them to grow their business, to do more business, create more wealth for everybody, really. And you're thinking, okay, is he going to come off his high horse soon? And not to worry, we'll sort of dive into a lot of the technical stuff briefly. I just wanted to really point to the fact that I think what we're creating with Tradeshift is unique, and it has scale. What is Tradeshift? So I've talked a lot about trade. I've talked a lot about moving dollars, right? So this is sort of one view, and you could say, seen from a technical perspective, Tradeshift is a platform born in the cloud. It's a true network of companies. So think LinkedIn, but for companies. So every company has a profile on the Tradeshift network, and they use their account on Tradeshift to trade, right? So basically to hook up on our B2B marketplaces, to find new sellers, new products, to find buyers if you're a seller, and then to perform that whole transaction. So we capture basically and facilitate all the exchange of purchase orders, goods receipts, invoices, payment notifications, and so on. And that sort of becomes our enterprise software suite that we sell into large multinationals. And then on the other side, we turn around and we actually offer financing to the suppliers on the network, which helps them get paid faster, right? So they don't need to wait for their buyers to eventually cough up the cash for the services or products that they render or delivered. So in that sense, we really have this flywheel going, where we are essentially a two-sided marketplace, all building this global network, which nobody else really is. If we look at Tradeshift as sort of tech by the numbers, right? Just to, again, give you guys a sense of what are we talking about. So we run a fairly large infrastructure on AWS, enough to have their attention as a strategic customer, which is good and bad. It means we're spending a lot of money. It also means that we get to regularly deep dive with the different AWS teams as they're bringing out new products, new managed services to really to shape what we're seeing there and have a great collaboration. We run, so it says 200 services running 1 to 4 added per month, and I'll come back a lot more to that, but really it is a microservices architecture, and we've done that. We've made that conscious choice with the extra added complexity that comes with running and deploying such a monster, because it allows us to optimize for team productivity. And we can see that by the fact that we do in the range, and I was just looking at these numbers yesterday, we did around 4,000 deploys to production of new code or change code during the last quarter, right? So we're looking at a rate of about 47 on average every day. We have 50 odd developer teams spread across the globe in Romania and Denmark, in the US, in Belgium, in China. Right, so truly a global company, which sort of also comes with lots of interesting challenges when it comes to collaboration. And as the world moved into COVID and lockdown, of course, we had lots of people for whom their everyday was disrupted, and we needed to start working from home. But we were also seeing that our culture and the way of working was very ready for this, right? So very distributed company. We process 2 to 3 million business transactions on any given day, and lots of businesses highly depend on Tradeshift being available. And that starts talking to some of the other qualities that are necessary of our platform, namely that it needs to be highly available, it needs to be dependent, it needs to be secure, and this is all data that our customers talks about a lot. Taking a look at a snapshot of what our technology stack sort of mainly looks like today, and there's a lot of logos here, but let me walk you through it a little bit. So on the front end side of things, nothing surprising to a very sort of modern oriented stack, right? React is the backbone of sort of the application framework on the JavaScript side. Redux, Jasmine, Webpack, all sort of in the build pipeline and so forth. HTML5, of course, as everybody else, and so forth. So nothing strange there, but also having sort of worked with many wonderful and talented front end colleagues over time, and the same thing goes sort of on back end technologies or any technologies really. We are, and we'll come back to this a little bit more, but as technologists, as engineers, we're always curious, right? What's the next big thing out there? Shouldn't we really be running everything in Haskell, or shouldn't it all be TypeScript or CoffeeScript, or there's this Node.js, and the whole NPM world is huge, and lots of development happening, but it also creates a temptation to start reinventing the wheel all the time. So one of the big sort of topics as we govern our technology as we move along is, when do we invest and what do we invest in updating or changing our reality? On the backend side, it's all running microservices, so it's all packaged in Docker. It's deployed to Kubernetes. There's lots of mucking or stubbing going along, and as a developer, you have a super nice setup with just your local stuff that you're able to run locally and connect out to stacks in the cloud and so on. Java, Spring, Node.js, Jetty is sort of par for the course here. On the DevOps side, and I think this is also where things start getting interesting, because this really ties the whole thing together. We are now running almost completely, save for a few things, in Kubernetes, and we've gotten all of our services to a place where they're fault tolerant, they scale up and down, and we can start really harnessing the power of being in Kubernetes. Using Linkerd as our site mesh gives us great observability together with Prometheus and Grafana. Vault for managing secrets means that managing certificates is no longer a hassle, but largely automated, and so on. On the storage side, we're not super advanced, but using true and tested technologies. Postgres is the heart and core of our of all of our database efforts. Relational database, I've worked with it for, I think, the past 15 years, and it's absolutely a monster, and serves us very well. Cassandra, that we use for a lot of our timeline-based storage, RabbitMQ for queuing, together with Kafka, getting great throughputs through Kafka, Elasticsearch for indexing / OpenSearch, of course, that whole thing, Redis for caching, and so on. So nothing surprising if you look at this through a lens of a, I think, fairly contemporary and current SaaS application. I think what's interesting is the space that we are in and that we're competing in the B2B space really is, the enterprise software space. And if you look at this technology stack through an enterprise software lens, this is like the UFO just landed. And we pride ourselves by being out there and being much, much more modern and able to move much faster with our whole product and technology stack than any of our competitors. Now, I wanted to talk a little bit about this sort of general theme of no such thing as overnight success. And what I just presented to you was a snapshot of where we are today. But it wasn't always like that. And it's not going to be like that always, because you always need to adapt and grow your organization and change your organization and your technology and so forth, your processes as you go along. So a little bit of a snapshot here. And I wanted to show, so this is a graph coming off of some of our production usage data, I believe number of invoices or some such. And it's, what I really want to show here is that as years went by, the first many years actually, it looked like we were on a sequence of linear sort of developments. And while they were accelerating, it wasn't clear that this was going to blow up. We believed it was, but the world around us probably thought we were slightly crazy until something happened, right? But that something didn't just happen. It was an accumulation of many, many years of efforts of go-to-market, of technology, of development, of sales, of customer relationships and growth and so on, right? But eventually the flywheel starts ticking and everything sort of takes off. So as we go through that continuous journey, what are sort of some of the things that we've learned from that, right? So architecture is all about finding the right fit at the right time. And for a lot of our systems now, when we build sort of new subsystems, they are born into fairly high load scenarios, but some are also not. And so every system that we have, we take through a growth path over time, because you don't want to invest a ton of effort upfront into making something that you later found out wasn't the right thing to build in the first place, right? You got to test it out, the whole thing about sort of lean startup and MVPs and proving out your assumptions and so on. So a lot of the times we take our systems through sort of an architectural journey as they need to handle more and more concurrent operations per second. And I won't sort of go through all the details here, right? But I think it is important to realize that for a lot of systems, you start out with an MVP, and you can throw up a super small RDS instance, a small ER data model, and you're good. And it can actually take you very, very far. You optimize some queries, and then you start doing all these things, right? You add some locks to handle concurrency correctness. You add some caches to get some performance gains. Then you start doing some indexing, both for sort of faster query times, but also just for search capabilities and so forth. At some point, you start thinking, oh, maybe this data model of having everything in an entity relationship, entity relational model is not going to cut it, and we actually need some journaling, either as event sourcing or sort of post-event journaling, and you sort of move out into like your column storage or something else that also scales vertically that way, right? But the main message here is you really sort of need to take your systems through this journey, and a few systems get born all the way, and I don't know which way the video mirrors here, but they get born up and to the right, but most systems start down to the left. The same thing goes for your CI/CD processes, right? as I mentioned, we did 4,000 deploys last quarter, and that is we didn't get there by accident. We've been working very deliberately to get there, right? So there's lots of things that go into enabling that kind of into that kind of a place. But a lot of it is looking at how can we automate as much as we can? Can we put automated checks around quality so we know whether we're regressing or not? And how can we make sure we optimize for team productivity so we remove friction in our build pipeline? And so today we're in a place where our teams can move very autonomously. They don't have to go through central congestion points in the pipeline where lots of work needs to be evaluated at the same time, and the world sort of needs to be at a complete standstill. They're just moving sort of very independently. At the same time, to get there, you also need to get things like feature flags and such in place to really make this work. And moving on here, when we look at the operations side of things, that's also, I had the experience recently of diving into another enterprise software system, which ended up being very much about logging into individual servers, bringing up some remote desktop on some Windows interface, clicking around in configuration options, or logging into individual Linux servers and running stuff. And I was sort of relieved and saying, wow, I'm so happy this is not Tradeshift. We're at a place where it's everything in our infrastructure is code, right? So everything is defined in either in Terraform or in YAML Helm charts, deployment charts for Kubernetes, or in other ways. It's all a build pipeline, also our infrastructure, and that means a lot, because it means you can sort of apply the full force of everything you do to manage software. You can apply that on your infrastructure, right? All your monitoring, all your sort of rebuilding, all of your replacing, upgrading, all of that stuff. You can really move to an automated place. Of course, it means that you can have a much larger blast radius if you make errors, but it also means that you can recover a lot faster. So moving through all of these, there's tons and tons of stuff to put in place. And I think for anybody who's on this journey, like you don't start up and to the right? There's of course lots of stuff that's now best practice, and you can get going super easily, and you design that from the beginning in. But there's also stuff that you will want to get there in due time, because of course putting all of this automation in place is something that only comes with a lot of investment, and so you got to make sure that investment actually has a payoff on the flip side. So moving a little bit ahead, I wanted to talk a little bit about high performing teams, and as I certainly have some literature recommendations for anybody that's interested in all of this, and I think some of this is becoming sort of a new standard and litany for how to organize around your software development. In the early 2000s, Agile was sort of fresh off the block, and everybody sort of oriented themselves around Scrum, around extreme programming, and then everything that sort of branched out from there, the lean software development, of course, playing a big part into that. I think today, I see it as a sort of shift for the whole industry, definitely orienting towards accelerate, which sort of describes with a fair amount of rigor, saying it's if you as an organization, if you're able to deploy fast, if you're able to recover fast, and your sort of idea to deployment time is fast, then you have a much higher chance of success, right? So how do you get there? And that's sort of the whole DevOps movement, right? You also have team topologies, which came out a couple of years ago, also backed by lots and lots of research sort of looking at Dunbar's number as and Conway's law as a sort of, if you look at those two and take those as truths, how do you need to shape your organization to optimize communication that allows for work to flow freely, and for people to have cognitive loads in your teams that actually put them in a space where they're able to make an impact to what they're doing. So accelerate and team topologies, I think are super important pieces of work, and then of course the Phoenix project and the Unicorn project by Gene Kim are sort of, I think, my four go-to books in shaping the thinking about how to organize and how to put our overall architecture together in a way that allows us to have these high-performing teams. So I tried to put together some of the factors that I feel reinforce each other. And if you get them all working, you get on a trajectory of getting things working better and better and better. And if you don't get sort of all of these elements somehow playing together, instead of a virtuous feedback cycle, you start disrupting that. Best case, you have no feedback, and worst case, you have negative feedback cycle, and your productivity plummets, right? So to me, it all starts off with continuous integration. And from there on, as the next step, actual continuous deployment. But continuous integration, for sure, is sort of the baseline. And with that comes sort of all the practices that are now sort of par for the course on GitHub, forked repositories, pull requests, reviews, and all that jazz. And of course, atomic builds on the component level, and so on and so forth. The next thing is to, I don't know if it's the next thing necessarily in order, but definitely a big part of it, decouple, deploy, and release, right? So when we have a code change and we put it into effect, we deploy that code into production, the question is, what impact does it have? And some code changes you want to just put out there and they just take effect immediately. Some of them you want to put in front of your customers in a much more controlled fashion, either because they need training or they need to be made aware of it, or they have, internal dependencies they need to work with, or, sometimes you just want to create a big splash and say, here is the new product and new suite, and it's really lots and lots of features cobbled together, and this makes a product. But that's a release process, right? Is all the market-facing activity, the customer-facing activity. But you also don't want it so you actually do the big bang release, right? You want that continuous deployment, lowering risk. So decoupling, deploy, and release. In our case, we do that both with our internal app framework, which is sort of our way of doing modules and enabling also third-party vendors to build applications on top of Tradeshift. But we also do it with our feature flag mechanism. We use Flagger as our library for that, tool for that. Then automating all tests, and that's simple. But I think what we've sort of been on a journey on over the years is finding out where to apply that automated test coverage, right? So unit tests, of course, gives itself, and probably most people sort of know about the test triangle and where you should put it and where you shouldn't put it. I think at some point we've gotten to now, we sort of have a test, I don't know, not exactly a triangle, but more of sort of a oval-ish shape. And then we have a blob of stuff that's actually running in production that mimics user flows to sort of make sure we're not getting, as a last resort, so checking up we're not getting regressions on the very end. But the key here is to not have any test points that create congestion in our build pipeline, because as your developer organization grows, your number of teams, number of developers, you want to make sure you're not having a point that everybody needs to pass through, right? Stop the line policies, which is a thing that we've adopted over the past couple of years. I think to great success is we had an issue with lots of work actually being hidden. So our teams would do lots of good work to update dependencies or resolve issues that were happening in production, or doing this tech renewal project or whatever. So at some point, that of course eats up any of the sort of free room you have in your planning and your prioritization and your commitments to customers, and that starts creating prioritization friction with our product management counterparts and so on. And so one way that we found to be particularly effective is to have these stop the line policies and resolution targets. So we have resolution targets on our bugs. And that sounds like, wow, do you really want to submit to that? And we have stop the line policies on error rates on our services, so error budgets. So services have an error budget. If they exhaust that, the teams have to prioritize getting that back in a range. And that's, of course, set high enough that we can keep our overall sort of SLA. All these are mechanisms that force prioritization for the teams, which means that it brings it out of the realm of discussion, because we've had that discussion up front about what is good enough. And now the teams say, okay, well, now when including our product management and our customer facing teams sort of realize, okay, these are things we need to deal with. Automating the tech governance. So we use, for instance, Dependabot, which comes with GitHub and tells you if you have dependencies that are out of date or have security vulnerabilities open against them, and fueling that in and getting Jira tickets created and tying it together with the resolution efforts or license compliance sort of things. But putting a lot of automation around that, I think, is key to what has helped us get to a place where these things just flow, right? Reducing friction in the pipeline by automation. So again, anytime there is a manual task, if that can be handed off to some automation, that is an opportunity to reduce friction and reduce cognitive load for the teams. So while it's an investment that pays off in the long run. The key to all of this is, of course, you can't have all the investments happen at the same time, because then you'll end up with a very shiny car that's completely out of gasoline, or dead on the charge if it's an electric car, and that fuel, of course, is the money that needs to bring you further as a growing company and startup, right? So you need to sort of balance your development over time. Technology variance is one that sort of an off discussion, and I hinted to that earlier, is when we look at things in 2, 3, 5, 10-year spans, having a lot of technology variance adds cost and drag and friction and complexity in your systems very quickly. So being able to make deliberate choices about adopting new technologies and deprecating old ones and moving off of that is what enables you to keep on moving fast, right? So you need to be able to do that somehow. With that, also innovating. So I think if we look overall, we've been at sort of 3 to 4 major paradigms of how we deploy and operate the Tradeshift platform, and we keep on renewing that as we go along, simply to keep current. And if you don't keep current, you end up being irrelevant in the market. The last one here is optimizing for team empowerment, control, and ownership. I think we've had different stages in our growth journey where we've optimized for other things, right? So both in our organizational design as well as sort of our code infrastructure design, where we've ended up in situations where we've optimized for maybe, say, the infrastructure team or the ops team to be able to do stuff, but at sort of at the cost of our feature teams having much higher cognitive load, because they needed to understand a lot of infrastructure stuff. So it was easy to do stuff on the infrastructure side, as an example, sort of changing configurations for all services or whatnot, but it was super hard for the feature teams because they needed in turn to understand a lot more of the internals of infrastructure. So they ended up having a much higher cognitive load. And
Rolf,
we're running
Rolf,
on time.
Rolf, yeah, I'm sorry. We're about 6 minutes over now. I know we had the technical issue, but if maybe we could have like 1 or 2 minutes wrap up, and then I'll
wrap up right now.
Oh, thank you very much. I'm sorry.
No worries. So the biggest secret of all of this, of course, is hiring good people and having good people on the team. And I see that some of our Tradeshifters are on here today, and feel free to reach out to them in the chat. And with that, I also want to make sure just to say we are hiring. in Romania, remote anywhere, or in office in Bucharest as soon as we get to a state where that can be open. So tradeshift.com/jobs. Thank you for your attention. I apologize for running over and apologize for the technical difficulties, but that was it.
No, it's all good, man. Thank you. I need a job, so I'll go apply. I just don't think I have the right skill set. So, but really appreciate you being here, Rolf. And hopefully we can see you in Transylvania next time.
I hope so. The travel will be more normal again.
Yeah, we hope so too. So thank you very much, Rolf.
Thanks.